Have you ever wondered why, when you drop a feather and a stone from the same height, the stone hits the ground first? This question might seem simple, but it leads us into a fascinating exploration of a concept called terminal velocity. Terminal velocity is a term used in physics to describe the maximum constant speed that a freely falling object eventually reaches, when the resistance of the medium through which it is falling prevents further acceleration. This occurs when the force due to gravity is balanced by the drag force acting on the object. Imagine a skydiver leaping out of a plane. As soon as they jump, gravity pulls them downward, causing them to accelerate. But as they pick up speed, the air resistance, or drag against them, also increases. Initially, the force of gravity is much stronger than the drag, and the skydiver continues to speed up. However, as their speed increases, so does the drag. There comes a point when the drag force equals the gravitational force. At this point, the forces are balanced, and the skydiver stops accelerating. They continue to fall, but at a constant speed. This speed is what we call the terminal velocity. It's crucial to note that the terminal velocity of an object isn't fixed. It depends on several factors. The weight of the object is one. More massive objects have a higher terminal velocity. The cross-sectional area of the object is another factor. Objects with a larger area facing the direction of motion experience more air resistance, which lowers their terminal velocity. Finally, the drag coefficient, which depends on the shape of the object and the medium it's moving through, also plays a role. So, to circle back to our initial question, why does a stone fall faster than a feather? It's because their terminal velocities are different. The feather, being lighter and having a larger surface area relative to its weight, experiences a great deal of air resistance and quickly reaches its low terminal velocity. The stone, being heavier and more streamlined, has a much higher terminal velocity. To summarize, terminal velocity is the constant maximum speed that a falling object reaches when the force of gravity pulling it downward is balanced by the drag force acting against it. This velocity depends on the weight, cross-sectional area, and drag coefficient of the object. Understanding this concept helps explain why different objects fall at different rates, and why, even in the absence of other forces, we don't continue to accelerate indefinitely when we fall. In the grand scheme of things, terminal velocity is one of those captivating phenomena that remind us of the intricate balance of forces that govern our universe. It's a concept that challenges us to dig deeper and ask more questions, pushing the boundaries of our understanding. So the next time you see a feather drifting leisurely to the ground while a stone plummets, remember, it's all a matter of terminal velocity.